So today we've got something I know you love. Pi, right? Everybody loves pi. It's a bunch of numbers. Well, this is pi. We're going to use some of these numbers in some math operations today. Yay, math operations! Woohoo! Okay, so maybe not the most exciting thing you've ever heard, but wait, we're going to do some cool stuff with it. I am more interested in doing things like painting and sculpting, doing nice little models, but technical stuff always creeps in. And honestly, I haven't really enjoyed math since, I don't know, grade 9. After that, it kind of just, I didn't like it anymore. But I found myself doing a bunch of math operations in Unreal and found myself actually really kind of enjoying it. So what we're going to do is we're going to create a little function. And you can do that by going materials and then create a material function. And I've got one opened right here, which is ready to go. So it's just got an output. There's nothing else going on there. And what we're going to do is we're going to start off with something simple, and we're going to gradually build ourselves up from there. I'm going to explain all the little steps as best as I can as we go along, and how you can look into it further. But ultimately what we'll do is we'll create ourselves a simple circle and something to allow us to create swirled UVs, and then we'll move on to a nice pretty flower. So let's get started. So the first things we're going to need, of course, is a gradient. The easiest way to get a gradient is to get a texture coordinate. So texture coordinate node, and there it is. And the texture coordinate node, as I've mentioned in my other tutorials, is just two gradients. So if we go ahead and create ourselves a nice component mask, so component, there we go, component mask, and we'll just copy that, Control C, Control V. We'll plug that in, and we'll change this one to just exclusively the red channel, and this one to just the green channel. Pull it out and open it. Pull that down and open it. And again, as we've seen before, we've got a left to right gradient and an up and down gradient. So I suppose the question right now is, why are we using gradients? Why do we need these things to start off with? Well, when we're creating shapes, 3D shapes, well, 2D shapes, I guess, we need to be able to plot them on a graph. And so plotting things on a graph typically means plotting them horizontally, and this is giving me an increment. It's going from 0 to 1 across there. So each one of these variables, or each one of these colors, equals a variable, a number. And then of course we have 0 to 1 going in the other direction. So the first thing that we're going to do with this is we're going to create a little bit of an offset. So we're going to do that by going and creating a subtract, and we're going to go ahead and it's already got the value of 1 in there, so that should be good for us for the moment. Actually, I want to do it this way, and I didn't mean to do that. There we go. Let's update that. So we'll create a vector 2. We'll plug that in. 1, 1. And actually, in order for this to work out, so with 0, nothing, it's gone black. We've actually gone into the negative, so I'm going from 0 to -1 right here. And actually what I wanted to do is go to both 0 to -1 as well as 0 to +1. And so in order to make this work, I'm going to have to multiply this by 2. So by doubling it and then going back by 1, what you should see now is this. So I've got 0 in the middle, and it's going to positive 1, and it's also going into negative 1. We don't see it because it doesn't show anything in the negatives, any color other than black. And we can see the green, and again, nothing there. So we're going to bring these puppies around and bring this back. There we go. And that should give us our 2 little values, and that's good. And we're good to get started with that. So because we have a wonderful negative positive thing going on here, we can do something a little bit different. We can go ahead and do a nice little multiplication. And what we're going to do is we're actually going to multiply it against itself. And we're going to get that. And what does that look like? Well, let's see. Let's look at it in good old black and white again, because sometimes that's easier to tell. So what we're seeing here is a gradient going from 0 to 1, and again from 0 to 1. And this is actually fairly useful. What happens here is that because I was going from 0 to negative 1 times negative 1, so a negative times a negative is a positive. Pretty simple, and that's what we're getting here. So we've got this ability now to plot from a middle outwards in multiple directions, which, again, as I said, is useful. Now, we're not going to use it for this purpose just at the moment. What we're going to actually do is we're going to add these two together. And let's see what happens. So take 1, and then I add the other one. And I should get this, right? No. No, we won't. Actually, what this is would have to have been an append. I'm adding black and white information to black and white information, and I get a circle. Wait, what? A circle? How do you get a circle? Well, it just happens to be that when these values crisscross, the in-between values lead up to this circular form. So it's an interesting way of grading a circle. So there's some other things that we can do with this, but ultimately well, let's go through a couple things that we can do actually. So I'll create a multiply up here. I will create a square root over here. I will create a cosine, I guess. A cosine. Let's do the fast one. That one. And if you're ever curious and you want to go exploring, you can go here under the math section, and there's a whole bunch of stuff. We've got the a cosine fast, arc sine fast, arctangent 2, and so on and so forth. So if we were to take this value as is, and let's plug that in, we get a circle. And we'll plug it into this one. Well, it's just 1, so it's not doing anything yet. Although the square root is a math operation in of itself, and what we get is more of a curved gradient, I guess, as it were, so that we get a nicer result off of that. So this is still fairly useful for something. If we were to go ahead and take this and multiply by negative, that would invert, that wouldn't work. We're going to do a 1 minus. So 1 minus is you take 1 and you subtract what's there. And so if you 1 minus 0, you're left with 1. And if you 1 minus 1, you get 0. And so it basically inverts this whole thing. So we can do that. And we're getting an inverted version. So the A cosine is giving us something with a soft border but mostly filled with white. If we do this one, we get a nice rounded version of this. And the square root, of course, we get a softer version of this. If I just plug this in, sometimes it's a little bit easier to see. You can kind of see the gradient there. So each one is a different level of general kind of harshness. So we're just going to leave that like that for now because we're going to use that with something else later. With this, of course, we can use our multiplication to make that border stronger. Get a stronger border overall. Another way that we can get a stronger border is actually using a different statement, which is an if statement. So we're going to go with if here, and we're going to take this and plug in it to A, and we're going to need 3 values. I'm just going to plug this off into here for now, and I'm going to press 1 and left click, and left click, and left click. So 1, 2, 3 values. So first off, if the value that is coming off of it, and we're looking at it right now, it's non-inverted. So if the value is looks like above the B value, whatever the B value may be, then we'll make that black, and we'll take this one and make it a 1. And if it's under that value, then we'll make it into a white color. And so this value determines our end result. So we start taking that up, and you notice that the circle gets bigger and smaller because it's based off that gradient. If we go ahead and make use of this one, we have slightly better control over the sizing. So the square root is providing us with a better overall control, so we can change the size back and forth using this. And because it's an if statement, meaning only if it meets requirement number 1 or requirement number 2 does it actually do anything, we end up with these results. So we end up with a pure black and white edge, which is nice and sharp and detailed, and because it's vector, it's always going to be a perfect sharp edge. So there's just some basics of this process, something that we want to kind of keep track of. Now, of course, there's some other things that we can do, such as we could take this statement, copy, paste, and we'll get a lovely little multiply node here, and we'll plug that in like that, and we'll plug this one in to this as well. But what we're going to do here is we're just going to swap these, so it's an inverted set of values. I'm going to change the size of that, and what we get is, of course, a circle that's an outline, and we can control thickness of that outline just through doing this, so we can get nice little rings off of these things. So there's basically lesson number 2 for creating these shapes, which is not just starting off with this overall thing, but thinking again about how you can get creative with different operators that you might be familiar with, or just basic logic, right? Thinking, okay, well, I've got one thing, and if I create another version of that and I do it the opposite way around and I subtract it, in this case I'm multiplying, so I'm getting, black, which is 0, multiplied by the value that's there, it's going to lead to 0, right? It's going to cut it out. So that's what we're doing here. We're just going ahead and cutting it out. So we could use this as subtract. It would also work, but multiply works just fine to get the results that we want. So moving right along, I'm just going to delete this extra stuff here. We'll leave this contraption off to the side. Some of these we're just going to get rid of because we don't really need them. I'm going to take this information, I'm going to pull it up, and we're going to go for something else. I'm going to grab these guys again, copy, paste, plug them in, and we're going to use a different math function here. So we're going to go look for the arctan, and we're going to use arctan 2. So if we Control Alt over it, you get to see supposedly more information, although the original information is good. So this is an inverse of a tangent operation, and you can see what it says there. You can read that if you want. I'll plug those in, and what that's going to give us is this. And what you may not realize just yet is this is actually providing us with a swirl. The visual information that's here is not immediately apparent, and we're going to have to work at trying to get it up there. So I'm just going to grab this, copy, paste, because technically this is two inputs. Maybe it isn't actually. Maybe I'll just leave that be. That'll be fine. And I want pi. Don't we all? Copy, paste, because I've already copied the values in, so I've got about 7 digits of pi. That should be enough. If you want, you can just look up pi and get more digits if you want, but that should be good enough for us for now. And we're going to actually add pi to this. So we're going to take pi into there and this into here, and that's going to give us that, and we're then going to have to get a better gradient off that, and so the way that we can do that is we're going to click there, and we're going to divide, but we're going to divide against 2 times pi. So I'm just going to hit M and click and change that to a 2, so it's going to double it, and I just get 2 times pi. That way I only have to have the pi information read in once, and that's good enough. And we're going to divide that, so that's going to go into bottom. In fact, why don't I take all of this to the bottom underneath and put that in and open that up, and now you see a nice softer gradient going all the way up to white. So that's giving us the ability to create essentially a swirl. So if we were to go ahead and create an append node, append vector, and we add that into our x and our y, we end up with some UVs that will create an interesting sort of distortion. It will basically create sort of a spiral effect. And we can increase that spiral effect by going ahead and applying more values to this, so you can make it even stronger. We can also make it weaker by just doing a simple lerp. So if I went and did a lerp between regular UVs and these UVs, changing that alpha value would mean it would transition between that, and you could animate that, and you would see it slowly start to twist from the center and kind of twirl more and more, and depending on how strong you made this overall append value, the better result you would get. Although I shouldn't be using this one, I should be using some regular proper UVs. These ones have been doubled already, so they're going to tile. So we don't really want that. Well, that's basically it. So we can use this for UV purposes. So not only did we create something that creates circles, but through a couple of math operations, we created something that can twirl and swirl different graphics. So what else can we do? Well, we've gone through this interesting little process here to the point of arc10, and then if we were to go directly into the divide instead of using the add, we should be able to get something off of this. So we're going to change this up, and we're going to go directly across, and that's going to look kind of crazy, so we're just going to disconnect. Just get rid of that, because we're going to do something else funky with this. We don't need that add anymore. But I keep pi around because we always need some pi. How much am I going to milk that joke? I don't know. Anyways, okay, so we've got this, and what I want to do is I want to get fractions from it. And this thing right here, this gains a new purpose. This is going to be my, click properly, number of petals, because we're going to make a flower. We're going to use the same information, what we had built up to this point minus the add, and we're going to create some flowers from it. So I'm going to take this and directly from the divide with these numbers, this is now going to control that because it's rooted in pi. We're going to create a frac node, which is fractions. So if we just control Alt on that, and you can see it takes in values and outputs a decimal part of those values. So if I go ahead and take this and I can plug it in, and you look at that, I get this, which is actually fairly similar to what I had before, except that it's been flipped around. It's going the other direction. And we could combine that with this, and actually we would end up with a the same kind of idea, again, another swirl. So we could use that for that purpose. And that's basically the function that we have already in existence to do this. But we're not going to stop there. We're actually going to go a little bit further. So we're going to play with a couple other math functions. I've got these math functions put into my Gerstner wave video. So we're going to go with sine, and we're going to go with cosine. So keep in mind that a lot of this stuff was me playing around, a little bit of trial and error, and having quite a bit of fun with it. So we're going to take this and we're going to create some multiply nodes, and we're going to do what we did before, which is multiply them against themselves, because we know that part of this is negative, and this gives us a nice little mirror effect, which is kind of cool. Let's go ahead and mirror both directions, and we're going to go ultimately crazy, and we're going to just provide ourselves with, how about a divide node? I'm going to divide these. Oops. And that's going to give us this funky shape. So let's take a moment and check out what this does so far. Produces that. I'm just going to go ahead and put a clamp value on here, which is going to lock it between the values of 0 and 1, because going above those values is what's making it glow. As soon as you put any value that goes above the value of 1, it starts to glow. So we're getting this, and I'm plugging into this because this will update as I change the values. So we're going to take this and we're going to upgrade that, and then we're going to downgrade that, and we're going to downgrade it some more, and some more, and some more. And look at these cool patterns that we're getting off of here. So that's a starting point. It's something that's kind of interesting. You could use that in combination with the circle symbol to do sort of like maybe an Asian theme thing or some symbology related stuff, which would be kind of cool. But we're going to go a little bit further, and what we're going to do is we're going to go and do a 1 minus. So I'm going to hold down O and left click, and we kept this around for a good reason, because we want to use it. So that's going to, you know, invert that. We're going to create a power node, which is going to allow me to control the overall size of this. And we're going to create a multiply node, which is going to control our harshness of that circle. So let's move that out. And now we're going to go completely crazy and create another multiply node. And we're going to multiply these guys. And what you see is this. So we've gone from this to this. Cool, pretty cool. Let's get a little bit cooler. Let's go ahead and copy, paste. I'm just going to get rid of that clamp. Plug that in, plug that in, create another multiply node, and we will invert and change that value. Take it up. There we go. So this is going to control the thickness of our line. There we go. And watch the properties that happen from these guys. So I'm going to create a couple other parameters here. Plug those in. Right now they're set to 0. We don't want that. We'll set them to their usual defaults, which is like that. So it goes back to how we were. Convert these to parameters, and we're going to go with roundness and scale. Oops. Yeah. I paid attention to what I'm doing and make sure it was actually ready. Scale. We'll do that. And where's that? So convert that to a parameter and say number Again, it's not ready for writing. Num petals, just to keep it short. So if we do that and we save it, these will become active, which means they will update faster. So if we go ahead and change that value upwards, we can play with these. So the number of petals. And then with this, I start to drag it up. They get narrower. It's changing size a bit, but if I start dragging it to these lower values, you're going to notice that the petals start to open up. And that's making the width of the petals wider. So maybe it would be better to call this petal width, maybe. So nice rounded petals. Let's get them sharper again, something like that. And we'll change the width more and more. And check that cool stuff out. So this is allowing us to create this cool little flower thing. But wait, there's more. There's more. How about I change the number of petals and really start to change that number of petals and really change that number of petals. Look at that, we get a nice little heart. And if I go ahead and change that roundness value, this petal width, I can change the style of that heart a little bit to something kind of cool. So say something like that. So right now it's going the wrong direction, and I believe that would have to do with this guy right here. So we're going to go ahead and do a how about a multiply by -1 for this guy. So keeping in mind that 1 minus is often an invert node. It doesn't always count as an invert node in all cases. So in this particular case, I need to do a negative multiplication because I'm dealing with negative values as well as positive values, and that's going to flip that information for me properly. So now I get the heart in the right direction when I want to actually use a heart. So there we go. We could do something a little bit more. How about we take another look at this? So where there's one dot, you can have many dots. And you can have many dots by doing, say, 10 and 10. And notice I only get one heart and I get an offset for that. But what I should be able to get is a number of hearts or a number of lines. And I'm not. I'm getting these values that are going above. So let's think about what is it that I could use in order to get the effect that I wanted. I can take this information and make use of my good friend cosine. Copy, paste, and we'll plug them in. And what you're going to notice is we're getting a whole stream of these things. Let's go down to, I don't know, 5 and 5. So that's there, but it doesn't look quite right. Let's bring it through to the end and just confirm that. Look at that output. So we've got this gradually shrinking kind of effect. Something that doesn't feel quite right, honestly. So let's look at where we're going wrong here. So my issue is I'm multiplying a multiply when I want pure values. So I'm going to take this like that and get rid of that multiply, and now I've got straight values. So that's good. I'm going to take those and plug them into here. We'll plug that out, and what we should start to notice is we're getting some interesting results here. So if we look at this, we get these squares here. We're getting a tiling pattern. And these are controlling the intensity of that. It's going all over the place. Inverting them creates an interesting sort of tile pattern, but we're no longer getting the results that we had before. So what we want to do here, I believe, in order to get some more hearts, would probably be a multiplication. Let's see if that gives us back what we want. And it does not. So thinking through this, I need circles, circular gradients, versus this. And I need that twirling function, but I need it multiple times over. So I don't need a stronger version of this, I need this to tile. And that's where my problem is coming in. I'm not getting that. So what I need is this function to have multiple versions, multiple variants of that as well. So that is again going to require some creative thought, because I need to go negative to positive as I have here, and well, on that flip that we have right here, which doesn't look quite accurate, but often cases these things don't look quite accurate, but that's fine. So I need to recreate this to tile multiple times at this level, and that I think might work here. Let's see if I take these ones, because these used to be multiplications, but they're not anymore, and I go here, do I get a repeat? And look at that, we do. Ta-da! So we get a whole bunch of these lovely little hearts, and they're flipping different directions, and we've got ourselves a winner. So there you go. So tiling the hearts, tiling all that kind of stuff, we just have to be a little bit creative with it and see what we can produce. I think if I were to just go directly to this, it tiles the other way. So it still functions, but it just tiles the other direction. So they're mirroring each other along this axis. So go forth, experiment, play, have some fun, and see what you can do with all this cool math stuff. So again, you can use this to create polka dots, hearts, flowers, various different shapes of flowers. You can go into some clover. I did a whole bunch of random experiments myself over here. Combining two different sizes of polka dots in order to get interesting patterns there. I did another series of experiments of different math functions, just trying different stuff based on that same root information, and led myself to create a clover in one instance, and that was kind of cool. So it's similar in some ways to the flower, not exactly, but it's kind of similar. Again, using those multiplications that we've got there, we get this, and then I multiply it against itself, and I get those prongs, and then I multiply it against the inverted circle thing, which softens the edges, and applying it to a sign gives me those indentations there, and I get this pattern. And another exploration got me this kind of asterisk form, which again is based off a lot of the same kind of stuff. I found a pure heart formula, and so masking it in, 1 minus 0.25, that's the offset, so we're just kind of changing the position of the gradient with an add. That's all that does, is it just shifts it up and down, and then we multiply it by 5 and then divide it by 4. And for this one we're using ABS. ABS is doing similar stuff to what the multiplying it by itself does, in that we get only positives, and then doing a square root changes its fall off, and we're grabbing a copy of that, multiplying it against itself. So you can see the difference between the ABS versus multiplying it by itself. The gradient is slightly different. Anyways, we're taking this and the square root, and we're subtracting this from this to give us this, multiplying it against itself, and adding it to this. And the end result is this really soft gradient heart, which we then use to cut out, and we get this cool little heart. And this one is perfectly centered. So hopefully you've learned enough about these different equations. I'll just pan through this one so you can see it. This is in its pure form, where it's not linked to a whole bunch of the other junk, moving its way through and in. And what you see here is that circle, which is coming off of an inverted version of that. Sine wave, and then the if statement to sharpen it up, and you can change the scale of all that stuff. So there we go. Hope it was interesting. See you in the next video.